and welcome to our last video on Riskier's True Code Analysis tool. In this video, we will show you how to use generic static analysis checks in True Code. So far, we have shown you many videos on how to configure the settings in True Code, how to manage annotations, context, and how to prepare automated code checks. One of the most important parts of True Code is how to configure the clang compilation database. As we've said in a previous video, True Code needs to compile the source code into LLVM-IR in order to analyze efficiently. True Code has the simple option to compile the code of the developers from a compilation database. By clicking Clang Compilation Configuration, we can see that there are 6 configuration items. In Clang arguments, we can influence how Clang operates by adding command line arguments. For example, we can change the target for cross-compilation on another platform. We can also update the invalid absolute paths as determined in the compilation database with string replacements. We can block the compiler flags from the compilation database which are not supported by Clang to avoid errors. We can define the absolute path to system include folders. Optional additional include paths. By using the search button, True Code will search all folders for all projects which contain inc or include and add them to the list. This may not be necessary if the compilation database is complete. And lastly, we can add headers containing pre-compiler variables needed for Clang. Again, this is not required if the compilation database provides successful compilation. After the compilation database settings are configured, the code checks can run. However, these checks may give some warnings depending on the environment of the user. For example, if the user is using Linux and there are flag configurations for Windows, True Code will produce some warnings. As a result, we must decide how we should handle them. To do that, we go to Generic Static Analysis, where there are 2 configuration items. The file context, which will allow the user to select a list of context items to be analyzed. And the filtering of the results. We can see that there are a lot of options here. That's because the number of checks by the static analyzer and the number of compiler diagnostics are huge, so we can block some, or all of the findings and diagnostics which contain given text. We can also see that there are some pre-made categories of warnings. The errors, which contain all the possible errors that can be found. The conversion, which contains the warnings of variable conversions. The unused, which stands for the variables or parameters that are never used. And the unsorted items. The user can also move an item from one category to another, or create a custom category of warnings. This advanced feature of True Code helps the user to reduce unwanted warnings, errors, and optimizes the code review process. We can also see that the generic static analysis check is placed in the top of the code checks. This is because by setting filtering on the results in the very beginning, True Code will discard all the false positives and unwanted warnings and speed up the process. This was our last video on True Code, the first analysis tool for automated code evaluation. Thanks for watching, and good luck with your security evaluations.